In this video, we're going to do some examples with derivatives that include the new derivative rules we just learned, the derivatives for inverse trig functions and for log base a of x. So those derivatives that we'll take are the following below. Y equals arc sine of 3x. Again, that's the same thing as as sine inverse of 3x. Y equals cosine inverse of square root of x. Same thing as arc cosine of square root of x. F of x equals tangent inverse of 5x squared plus 10. H of x equals cotangent inverse of natural log of x. G of theta equals log base 2 of theta squared. Y equals x squared times sine inverse of 3x plus 1. And finally, y equals log base 5 of x squared divided by arc cosine of 7x. All right, so I'd like you to pause and try those out, and we'll talk about them one by one. Okay, for the derivative of arc sine of 3x, or sine inverse of 3x, recall that we found this derivative. The derivative of arc sine x in general is 1 over 1 minus x squared. So for this case, y prime, it's going to be 1 over the square root of 1 minus, and the inside function is 3x squared. Now this is a chain rule where 3x is the inside function, so we still need to multiply by the derivative of 3x, that's just 3. And we're left with y prime is equal to 3 over the square root of 1 minus 3x squared is 9x squared. And that is our first derivative. Next, we've got the cosine inverse of square root of x, or arc cosine of square root of x. And we know the derivative in general for arc cosine of x. So then y prime is, again, this is a chain rule where square root of x is the inside function. So negative 1 over the square root of 1 minus, and then instead of just x, it's square root of x squared, multiplied by the derivative of the inside function. That square root of x we often write as x to the 1/2 in order to take its derivative more easily. So derivative of 1/2, x to the 1/2 is 1/2 times x to the negative 1/2. And so we could simplify this. This is negative 1 over the square root of 1 minus square root of x squared is just x. And then it's also multiplied by 1/2, so we could put that 2 in the denominator here. And then we've got x to the negative 1/2. That's the same thing as a square root of x on the bottom. And we could leave it like that, or we could write it as negative 1 over 2 times the square root of x times 1 over x. We could put that both inside the same square root. And that is our derivative. For tangent inverse of 5x squared plus 10, we have our derivative of tangent inverse or arc tangent of x over here. Again, chain rule, this is the inside function. So it's so f prime of x is 1 over 1 plus the inside 5x squared plus 10 squared, multiplied by the derivative of the inside, multiplied by 10x. Derivative of 10 is 0, so that's that. And then f prime of x, if we simplify it, that's 10x over 1 plus 5x squared plus 10 squared. And we could multiply out the bottom, or we could just leave it as is. For the derivative of cotangent inverse of natural log of x, we know the derivative of arc cotangent of x, or cotangent inverse of x, is this. The negative of the derivative of tangent inverse of x. So again, chain rule, ln of x is the inside function. H prime of x is negative 1 over 1 plus, and natural log of x is the inside function squared, multiplied by the derivative of the inside function, multiplied by 1 over x. And so we are left with negative 1 over x times 1 plus natural log of x squared. For our next function, we've got g of theta is log base 2 of theta cubed. So g prime of theta is 1 over the natural log of the base, natural log of 2, times the inside function, theta cubed, and then we're going to multiply by the derivative of the inside function, so that's 3 theta squared, and when we could rewrite that, that's 3 theta squared over natural log of 2 times theta cubed, and so we could simplify that. G prime of theta is theta on the squared on the top and the bottom cancel, 3 over natural log of 2 times theta. X squared times sine inverse of 3x plus 1. We need a product rule here because those two terms are multiplied together. So y prime is the first, that's x squared, times the derivative of the second, that's 1 over the square root of 1 minus 3x plus 1 squared, times the derivative of the inside, that's just 3, plus the second sine inverse of 3x plus 1, times the derivative of the first. The derivative of x squared is 2x. And so that means that y prime, when we simplify, is 3x squared over the square root of 1 minus 3x plus 1 squared, plus 2x sine inverse of 3x plus 1. So just rewritten, not really simplified. And that is our derivative. Lastly, we've got the log base 5 of x squared over arc cosine of 7x. For this, first of all, we're going to need a quotient rule. So y prime is the bottom, arc cosine of 7x, times the derivative of the top. The derivative of log base 5 of something is 1 over natural log of the base times that something, x squared, multiplied by the derivative of the inside. The derivative of x squared is 2x, minus the top, log base 5 of x squared, times the derivative of the bottom. Derivative of arc cosine is negative 1 over square root of 1 minus the inside squared, so 1 minus 7x squared times the derivative of the inside, that's 7. All divided by the bottom squared. So all divided by arc cosine of 7x squared. So that is our derivative. We could do a little bit of work to try to simplify. So we have that. We've got an x and an x squared. Part of that can cancel out. Let's see. So when we rewrite, y prime is arc cosine or cosine inverse of 7x times 2 over natural log of 5 times x minus log base 5 of x squared times 7 divided by the square root of 1 minus 7x squared, all divided by arc cosine of 7x squared. So there are other things we could do. Maybe we could break up the fraction and get rid of arc cosine of 7x in the first term, but it's not in the second term, so we can't get rid of it there. There are other things we could do, but we can also just leave it as is. One comment, each of these times where we have arc cosine of 7x or log base 5 of x squared, or, we cannot separate, say, this x out of arc cosine without using some trig function. So, for example, this x and this x do not cancel. This x squared and some x down here cannot cancel. It is log base 5 of x squared, a function of x squared. It is not, able to be accessed without using special either trig formulas or algebraic formulas to do so.